Explicit and recursive sequences. Finding the terms. What are they? Sequences are a list of numbers or objects in a special order. Why? Helps to predict, evaluate, and monitor the outcome of a situation. Interesting fact. Male polar bears can weigh up to 680 kilograms or 1,500 pounds. Now, let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1. Let's read the steps. Step 1. Explicit or recursive. Step 2. Substitute. Step 3. Follow order of operations. Now, let's read the question. List the first 4 terms and the 10th term of the infinite explicit sequence, n all over n plus 1. Let's find the first term, or a sub 1. Since we want the first term, we substitute 1 into each n, so we have 1 all over 1 plus 1, which is 1/2. Let's find the second term, or a sub 2. Since we want the second term, we substitute 2 into each n, so we have 2 all over 2 plus 1, which is 2/3. Let's find the third term, or a sub 3. Since we want the third term, we substitute 3 into each n, so we have 3 all over 3 plus 1, which is 3/4. Let's find the fourth term, or a sub 4. Since we want the fourth term, we substitute 4 into each n, so we have 4 all over 4 plus 1, which is 4/5. Let's find the 10th term, or a sub 10. Although we have a higher number, we still follow the same process. What do you think is the 10th term? Let's find out. Since we want the 10th term, we substitute 10 for each n, so we have 10 all over 10 plus 1, which is 10/11. And there we have it. That is example 1. Let's move on to example 2. Now, let's read the question. Graph the infinite explicit sequence n all over n plus 1. We have added another step, which is step 4, graph. So we need some coordinate points. To form our points, we smash the term number and the output together. So our first point is 1 1/2, and our second point is 2 2/3, and our third point is 3 3/4, and our fourth point is 4 4/5. What do you think the 10th point is? That's right, 10 10/11. And those are the 5 points that we found. Now, let's plot those points. And the other ones in between are here, just in case. What do you think is the domain and range of our infinite explicit sequence? The domain is the inputs, or the term number, and the range is the outputs. That is example 2. Let's move on to example 3. Now, let's read the question. List the first 4 terms and the nth term of the infinite recursive sequence, where a sub 1 is equal to 2, and a sub k plus 1 is equal to 5 times a sub k, for k greater than or equal to 1. Let's write down the given. A sub 1 is equal to 2, which is the first term. Now we need to find the second term, the third term, and the fourth term. We must use a sub 1 to find a sub 2, and a sub 2 to find a sub 3, and a sub 3 to find a sub 4. Let's find a sub 2, which means k is 1. So a sub 2 is equal to 5 times a sub 1. Let's substitute 2 for a sub 1, and 5 times 2 is 10. Now we can find a sub 3 since we know a sub 2. Now let's find a sub 3, which means k is 2. So a sub 3 is equal to 5 times a sub 2. Let's substitute 10 for a sub 2, and 5 times 10 is 50. Now we can find a sub 4 since we know a sub 3. Now let's find a sub 4, which means k is 3. So what do you think a sub 4 is equal to? That's right, a sub 4 is equal to 5 times a sub 3. What do you think we substitute for a sub 3? That's right, 50. And 5 times 50 is 250. Now we found the first 4 terms. Next, we need to find the n term of the infinite recursive sequence. To do that, we need to remember what prime factorization is. Do you remember what that is? That's right, writing a number as a product of prime numbers. Let's start with a sub 1, and 2 as a product of prime numbers is just 2. Let's write 2 again. We will see why shortly. Let's continue with a sub 2, and 10 as a product of prime numbers is 5 times 2, or 5 to the 1 times 2. Let's continue with a sub 3, and 50 as a product of prime numbers is 5 times 5 times 2, or 5 to the 2 times 2. Let's continue with a sub 4. What do you think is the prime factorization of 250? That's right, 5 times 5 times 5 times 2, or 5 to the 3 times 2. Now all the numbers are written as a product of prime numbers. We can create the n term of the infinite recursive sequence. First, let's look at how many 5s are in each term. How many are in a sub 1? That's right, 0. And the number of 5s increases by 1 in each new term. We know 5 is in there somewhere, but what is the power? Is it n minus 1, n plus 1, or something else? That's right, n minus 1. Finally, we can write down times 2, since that is in each one. That is example 3. Let's move on to example 4. Now, let's read the question. Graph the infinite recursive sequence where a sub 1 is equal to 2 and a sub k plus 1 is equal to 5 times a sub k for k greater than or equal to 1. We have added another step, which is step 4, graph. So we need some coordinate points. To form our points, we smash the turn number and the output together. So our first point is 1, 2, and our second point is 2, 10, and our third point is 3, 50. What do you think is our fourth point? That's right, 4, 250. And those are the 4 points that we found. Now, let's plot them. If we were to plot the next point, do you think the point would be on or off the graph? I'll leave that up to you. What do you think is the domain and range of our infinite recursive sequence? The domain is the inputs, or the term number, and the range is the outputs. That is example 4. Now it is your turn, so go ahead and pause the video here so you can take your time to answer this question, and I'll show you the results in 3, 2, and 1. Did you get it correct? Super. If not, there's always tomorrow.